Welcome to doassignment-ca. In this video, I will demonstrate how to solve question 517 from Chapter 5. The problem involves a man attempting to support a load of boards with a weight and center of gravity at point G. The man is standing on a smooth floor, and we need to determine the smallest angle, theta, at which he can hold the boards in the shown position. We are instructed to neglect the weight of the man and the friction force. To begin, we need to draw a free body diagram. At point A, there is a force perpendicular to surface A, and at point B, there is a reaction force of the same magnitude. At point G, there is a weight force, W. We need to find the reaction forces as a function of angle theta and evaluate the smallest angle at which the man can hold the boards in the given position. To start, we will write the moment equation about point A and find the reaction force at point B. By writing sigma m a positive direction clockwise equal to 0, we get that the force B makes a counterclockwise moment about A, and the value is negative and equal to B times the distance, which is 3.5 feet. The force W makes a clockwise moment about A, so the value of the moment is positive, and it is equal to W times the perpendicular distance, which is 0.5 feet plus 4 times cosine theta. Thus, the moment of force W, plus W times 0.5, plus 4 cosine theta equals 0. From this equation, we can find that the reaction force at point B will be equal to W times 0.5 plus 4 cosine theta divided by 3.5. Next, we use the equilibrium of the forces in the y direction to find the force at point A. We get that A plus B minus W is equal to 0, so A is equal to W minus B. Substituting the expression for B that we found earlier, we get A equals 3W minus W times 4 cosine theta divided by 3.5, or W times 3 minus 4 cosine theta divided by 3.5. To find the smallest angle theta, we need to see where the reaction force will be equal to 0. This occurs when W times 3 minus 4 cosine theta divided by 3.5 equals 0, so 3 minus 4 cosine theta must be 0. Solving for cosine theta, we get that cosine theta equals 3/4, and thus, angle theta equals cosine inverse of 3/4, which is approximately 41.4 degrees. If we assume the reaction force at point B is 0, we can solve the equation W times 0.5 plus 4 cosine theta divided by 3.5 equals 0. This yields cosine theta equals minus 0.5 divided by 4, so angle theta equals cosine inverse of minus 0.5 divided by 4, which is approximately 97.18 degrees. Therefore, by increasing the angle theta, we find that when it reaches 41.4 degrees, the reaction force at point A will be 0, making this the smallest angle at which the man can hold the boards in a given position. Thank you for watching, and feel free to ask any questions in the comments section. Please like, subscribe, and share this content with your friends.